Hello everyone. So this video is part 2 of our classes videos rather. Uh, in this one we're going to go ahead and talk a bit more about class files and how they relate to the compiler, and then how you can go ahead and use classes further as a data type. For those of you who are familiar with languages like C or C++, or working with compilers in general, you know that you have to tell the compiler what files and how to take all of them, all your code, group them up, process them, and spit out your compiled application. With C#, you have a lot of that done for you behind the scenes. Yes, there is a compiler for C#, of course, and you could manually build your applications using it. That is not, however, the intention with C# and using applications like Visual Studio. Microsoft, being they, did not write C# with you having to go ahead and continue to mess with compilers on your own in mind. They wanted to simplify the process. What Visual Studio does, as an example of that particular compiler, it gathers all your files for you based upon the defined scope, okay, what namespaces and what projects over here in the Solution Explorer you're choosing to build. And it will then go ahead and handle the compilation of your code into an executable application. Now, how does this apply to classes? So far, you've seen adding a class to the same file as the program class, the one that is automatically given to you when you went ahead and created a new console app in Visual Studio. However, you don't need to put all of your classes and code into one file to make it work. You don't have to put everything into program.cs. That would, over time, become very messy, and on large-scale applications, as you can imagine, that would be very difficult to manage and very messy. Okay? One of the advantages here of using Visual Studio and a compiler is that, again, you don't have to put everything into one file. The compiler, based upon your scope of your application, will know what files to include. So we're going to go ahead and define a new class in its own file. Over here in the Solution Explorer, right-click on the project. Okay? Not the solution, just below that, right-click on the project and do Add, and then Class. Now, a side note, for those of you who are on a Mac, this will look slightly different, but the steps are and screens are essentially the same. Okay? I believe your Solution Explorer is on the left, but you still want to right-click. You still want to do Add New, or I think it says Add Class possibly. But what we're trying to get here to is the Add New Item screen, where we can select that we want to add a class. And then we can go ahead and name that. I'm going to call it New Vehicle. And we'll click Add. And that goes ahead and that gave me a new class in its own file. If you look over in the Solution Explorer, you'll see new vehicle.cs along with program.cs. Now, I'm going to go ahead and go back to program.cs. And here in the main method, I'm going to start typing new vehicle. No, it's not showing up. Let's see real quick. The namespaces are different. Go ahead and, this is from a leftover project. If you go ahead and in new vehicle change the namespace to also be classes, save it, and then go back to program.cs. If I start typing new vehicle, it sees it. They're in the same namespace, so they are within scope of one another. And therefore I can go ahead and see it in my code, and I can create an instance of it. The on the fly, it's not a compiler, but what's going through and looking at your code and analyzing it recognizes that both of these classes are in the same namespace. They are in the same scope. They will go ahead and when I compile my application, it's going to include this file, this class rather, alongside this class and this class, all my code. Then they'll all be able to interact with each other both here in the editor and obviously with my compiled application. Now, something useful about classes being essentially a custom data type is that you can use them like most data types. For instance, you can make a list of a user-defined type. So let's go ahead and say I want to go, let's put some space here so that you can see what I'm working on specifically. I'm going to say I want to create a list object. And I want that list to be of type vehicle. I want to have a list of vehicles. See how I can use vehicle as the data type that this list will contain? It's going to contain vehicles, much like Visual Studio wants me to call it, vehicles. Equals new list vehicle, and there we go. What you're seeing here is a class that was instantiated but isn't. Oh, wait. Sorry, got a little ahead of myself. Now let's go ahead and let's add a vehicle to this list. Go ahead and go to vehicles dot add new vehicle. I have now gone ahead and instantiated an instance of vehicle, but it hasn't been assigned to a singular variable. Behind the scenes, what it's doing is saying, hey, each item in this list of vehicles, okay, can be stored as a single instance. Okay? It's headless. Okay? You don't need to have individual variables stored in the list. You can just give it the object and it can store it inside the list on its own. I don't have to first assign it to a variable in order to do that. Again, to some people, you may call this having a headless instance of an object. It helps me understand that this is not pointing back to a variable, but I can reference it based upon its location in the vehicles list. Now, our vehicle object has some public variables, which we didn't do anything with. So we could instantiate a headless instance and still access its public variables. Okay? To do that, I wanted to add a vehicle here, and I wanted to add it as headless. I could still say, just like we did here, then as you guys saw above when we set that num tires to 10, I could then do the curly braces and be able to go ahead and access these variables. This is going to go ahead and just like right here, it's going to add a single vehicle to the vehicles list. And this one is going to have 6 tires and is not running. The first one is going to use all the defaults. So it's going to be 4 tires and running. This one is going to have 6 tires and not be running. Another way to do the above is to modify our constructor. Now, right now, our constructor takes in 1 parameter. It can take in more parameters. We could have a bool is vehicle running, and by default we want to say true. It is, which makes this next part redundant. We don't need that. And we could say this dot is running equals is vehicle running. So by default we're going to have still a car or a vehicle with 4 tires and it's operational. Or we could go ahead and do something like this. Let's add to the vehicles list. We're going to add a new vehicle. And we are going to go ahead and pass our values in our constructor. It's got 2 wheels and it is operational. Now, we further could change this to say, hey, I want to add a range of vehicles. Okay? I'm going to go ahead and just put this in here real fast. Say call vehicles.addRange as opposed to add. Add only allows you to add 1 item to the list. Add range allows you to add multiple. Now, you can see here, here's my new vehicle and then another new vehicle. And they're both wrapped between curly braces, which follow a declaration of a new vehicle array. Add range allows you to pass in a collection. In this case, we're going to pass in an array of vehicles. The array essentially disappears after this point. It's just used to go ahead and hold our collection so that we can add to the vehicles list multiple vehicles all at once. So right here you can see you can go ahead and create a list of a custom user-defined data type. Okay? You could use this in dictionaries. You could use this in arrays, as you're seeing right here. You can go ahead and declare instances of variables in user-defined objects in multiple ways. Okay? And based upon whether or not you have public variables, whether or not you have a constructor where you take in parameters, all these things, you can go ahead and set up your instances of your objects with different values, and you can do it in different ways, whether it's using the public variables or whether it's using the constructor to do so.